All right, we're going to kick off our next unit, Unit 8, all right, and Lesson 1 here. And what we're going to work on in this particular lesson is, all right, just some skills that you're going to need within context of some of the other problems that we're going to work during this unit with our trig work. So we're going to focus on simplifying and combining radicals. We're on page 91. And really what we're going to do is we're going to simplify radicals, we're going to multiply and divide radicals, and we're going to do something called rationalize with radicals. So you can look at standard 18.1 here. I can perform operations on radicals and write my answers in simplified forms. All right, so just to get you thinking about this, all right, and make sure you understand what a radical is, why don't you pause the video and circle all the examples of radicals you see here in the opener, and then flip it back on, and we'll see how you did. All right, so you can see here that a radical is, or a square root, right? It's some type of root, right? And so we have two different roots here. We have root 3. All right, so had to pause the video there and let the announcements go so you guys didn't have to listen to those as well. All right, so, and then what we're really going to focus on are square roots. All right, so we're going to look at anything that looks like this. Now, what you're going to learn as you get into Algebra 2, pre-calculus, right, there are different types of radicals. So we could have a cube root, we could have a fourth root, but we're going to focus on square roots for what we're going to do in geometry this year. So today we're going to learn how to simplify radicals. We're going to learn how to, all right, multiply and divide radicals. And we're going to learn how to rationalize radicals. All right. And so those are 3 skills that we want you to be able to feel comfortable working with once we're finished with this lesson. So we're going to start with simplifying. All right. Now, and when we think about this, what a square root is, right? So a square root is the opposite of a square. All right. So when we think about like 4 squared, we get 16, right? So we square 4. All right. When we take the square root of 16, all right, that's going to reverse that, and it's going to take us back to 4. All right, and if we think about that, that's 4 times 4. All right, so the square root. So what number times itself, right? So the square and the square root are inverse operations to each other. All right, so we're going to simplify radicals. All right, and what we're going to really look for here, so using, all right, what we know about our perfect squares, right? So when we look at simplifying, what we really want to do is look at the factors of each numbers. All right, and then what we want to look for are our perfect squares, right? Because the square root of a perfect square, all right, okay, and so we want to look for perfect squares that are factors, okay? All right, and so here's what we know, right? So like we think about our perfect squares. I'm going to write them out here in the margin, right? So we have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, right? And so these are the numbers that we really are looking for when we're simplifying, because we know if we have a perfect square, we can take the square root and we get an integer answer instead of a decimal, right? So when we think about all of our, I'm just going to write the first 10 here. All right. Whoops, so 10 squared is equal to 100. All right, so these really are the numbers that we're looking for as factors, right, within each number. All right, and so when we look at a number like 80, what I want to think about is what's another way I could rewrite 80 as a product of 2 numbers, and hopefully one of those 2 numbers, all right, is a perfect square. So when I look at 80, I think, oh, it's 4 times 20. So notice I could do this, square root of 4 times 20. And the reason why I like this, all right, is this really, when we multiply inside, we can break this into 2 radicals. So this is square root of 4 times the square root of 20, like that. That's one of our properties of radicals. And the reason this works out well is, notice, square root of 4, that's a perfect square. Square root of 4 is 2. So I get 2 times the square root of 20. All right, now, but you may not be done. So what you always have to do is keep looking to make sure there are no perfect squares left. And so when I look at 20, notice 20 is 4 times 5. And so I have another perfect square, all right, which is 4. So once again, I can look at this as 2 times the square root of 4 times the square root of 5. And then the square root of 4 is 2 again, so I end up with 2 times root 5. And notice that gives me 4 times root 5. And that would be my final answer. This would be my simplified answer. Right, so no decimals, All right, so it should be, all right, an answer that has a square root in it if we don't have all perfect squares or if our first number is not a perfect square. All right, now, notice it took me twice to reduce here, and that's because I didn't find the biggest factor, all right, that was a perfect square within 80. So notice if I had seen this, if I knew this, I could have said right away that this was 16 times 5. All right, and then the square root of 16, right? And then I would say, oh, that's square root of 16 times the square root of 5. And then the square root of 16, that is 4 times the square root of 5. All right, and so notice if you find the biggest perfect square that's a factor, you're just going to reduce in a much faster way. All right, but that's really the key. And so you just want to start going through and looking for factors, right, that are perfect squares. So when I look at 80, really I should have started right here with my list. I should have said, okay, does 64 go into 80? Nope. Does 49 go into 80? Nope. Does 36 go into 80? And when I say go into, divides into and gives us an integer result, right? We don't want any decimals. That doesn't work. Does 25 divide into 80? No, that doesn't work. Does 16? Yes. All right, so if you kind of think about this number giving you a starting point within your perfect squares, you can kind of work down the list, and hopefully then you find the biggest one right away, and that's just going to save you time. All right, so let's go ahead and flip. All right, okay, and then I'm going to skip problems 1 and 2, and I'm going to go down here to the notes, right, on multiplying and dividing radicals. All right, okay. All right, so when we multiply or divide radicals together, they have to be, they are the same root. All right, so that means they have to have the same root like this. Okay, so and like I said, we can have cube roots, we could have fourth roots. All right, we have our square roots. All right, which is really a 2. We just don't write it there. All right, and so as long as we have the same type of root, all right, same type of radical, all right, then we can simplify. All right, and multiply and divide with those. Now, the way this works is, all right, okay, it's all multiplication. And whatever's on the outside, I can multiply together. All right, okay. And then whatever's on the inside, I can multiply together. Okay, so notice 2 times 4, that would be 8. And then 5 times 2 is 10. So I get square root of 8, or excuse me, 8 times the square root of 10. Okay, all right, so whatever's on the outside multiplies together. So the outsides multiply together and the insides multiply together. Okay. Now, once again, once I get to this number, I have to check and see if I can reduce the number, all right, inside the square root radical, just like we did on the prior example. Okay. Now, notice when I have my division right here. Okay. Now, what this means is when I'm taking the square root of 1/4, I'm really taking the square root of the numerator and the denominator. So I could really rewrite this as 2 times the square root of 1 divided by the square root of 4. And by doing this, that means I can then simplify the numerator as like a separate problem and the denominator as a separate problem. And then notice we know what the square root of 1 is. That is 1. The square root of 4 is 2. Right? And then now, 2 times 1/2 is, all right, 1, and there's my final answer. All right, so going through this, right, just be good about, all right, looking and making sure you can reduce everything. So let's do a couple of examples here. All right, so I'm going to do number 3 here. So once again, notice I'm going to multiply what's on the outside, that's an 8. And I'm going to multiply what's on the inside, and that gives me the square root of 12. Now, once again, I have to look on what number I have on the inside, and do I have a perfect square that's a factor of that number? And since I have 12, I do, because this is going to be 4 times 3. And then once again, this is 8 times the square root of 4 times the square root of 3. All right, and so now the square root of 4 is 2, so I get 8 times 2 times square root of 3, which gives me my final answer of 16 root 3. All right, so now let's look at number 5 here. All right, and when you look at your fractions, right, and you look at when I have something like this, right, I typically reduce the pieces on the outside and then the pieces on the inside. So notice 2 over 8, that reduces to 1 over 4. So I would reduce that just like I normally would. Now, the other thing is, just like we broke it apart, we can then look at the whole. And what that means is, right, I can kind of break this into 1/4. I made that really big. And then I can do this like square root of 14 over 2. So just like I can take the square root from the whole thing to the numerator and denominator, I can go back out. And what that allows me to do then is to reduce the fraction on the inside. And so notice this is still the 1/4, And then 14 over 2 is just 7, and that gives me 1/4 times the square root of 7. And then notice I can't reduce the square root of 7. The only factors of 7 are 1 and 7. Neither one are perfect squares, so then I can write my final answer either as 1/4 times the square root of 7, or you can write it as the square root of 7 over 4, because this is really like over 1, right? When we multiply fractions, it's numerator times numerator and denominator times denominator. All right, so let's take a look at one more idea here on page 93. All right, and then this is kind of an old school rule here. This really gets back to the days when we didn't have calculators and we had to get numbers into a way where we could estimate them or find decimals. All right, and what that meant was we couldn't have an answer, right, a result with a square root in the denominator. So what we do to counter that, all right, is we do something called rationalize. Now, when we rationalize, what we're doing is we're multiplying by 1. It's because when we multiply by 1, we're not changing the value of anything. But we're always going to multiply by a special 1. And what we're going to do, all right, when we do that, all right, is we're always going to multiply by whatever root or radical we have in the denominator. So notice, I'm going to multiply by square root of 5 over the square root of 5. All right, now notice square root of 5 divided by square root of 5, that's really just 1. So I'm not changing the value. All right, and the reason we want to do this is because when we do square root of 5 times the square root of 5, right, and I'm going to write this just right here, this is going to be the square root of 25, right? And the square root of 25 then is just 5. So that's why we're always going to multiply by the same root, because it's always going to give us a perfect square. All right, and then notice that makes this 15 root 5 over 5. All right, and then notice now I can simplify this just like I would, all right, if I didn't have the root 5 there. So it just becomes 3 root 5 over 1, or just 3 root 5. So the idea behind rationalizing is that we're going to multiply the special 1 every time, okay? So multiply the numerator and denominator by the square root you need to rationalize, right? So we're going to do that. We're going to simplify, and then once again, you always have to check and make sure, right, one, you don't have a radical in the denominator, but you also then have to check your result, right? Maybe, depending on the number I have in here, maybe I could have reduced that. All right, so let's take a look at, all right, and I'm going to skip to problem 7 here, just because it's a little bit more complicated. And notice there's nothing to simplify here. I can't simplify 2/5. Even if I pull the radical out, 4 over 3, excuse me. So then if I look in the numerator here, I can't simplify. And sometimes it's better to simplify before you start doing other things if you can. So notice the square root of 4 is 2. So this means my numerator then would be 4 over 5 root 3. And so now my simplifying is I need to get rid of that radical in the denominator. So just like we did above, I'm going to multiply by root 3 over root 3. All right, so 4 times root 3. All right, that's 4 root 3. All right, then I have my 5 here. Now, root 3 times root 3, and I'm going to write that right there, would be root 9. And we know the square root of 9 is 3. So then that gives me a times 3 right there. And then I just simplify that. So I get 4 root 3 over 15. And I have rationalized my denominator. I have no more radical than denominator. I can't reduce my fractions, right? I can't reduce anything inside the square root radical, so I know I am finished. All right, so wrap up this lesson, and I will see you guys next time.